So this is Expert Hunter and we are watching on YouTube. So let's understand today question that we have is 652. So this question we have to find the duplicate subtrees. So we have given root of the binary tree we have given, and we have to return all the duplicate subtree. So question is saying that for each kind of duplicate subtree you only need to return the root node of any of them, and then two trees are duplicate, then we have when the two trees will be duplicate, so if they have same structure and same node values, like we have given this one, right? Binary tree means two child we have, right? So this child contains what? 2, right? And similarly for this node another is containing 2, and this structure contains what? 4, and similarly it contains also 4, right? So this part is duplicate for this one, right? Similarly, so first what is saying that it is wait, we can do from here only. So first part is saying, first part it is saying that this part is duplicate. Okay. Oh, wait. So here, okay. So the first part is this. This is the you can say duplicate, right? Similarly, if you'll talk about if this is a node, right, and this is also a node. So new node is what? This is 4, and here for this one, this is also 4. So this part, and we are talking about this part. This is also duplicate, right? So first 2 and 4 is a duplicate, right? And similarly for 2 there is another node 4 we have, right? In both cases, here also and here also, right? Here also and here also. So another is 4 is there, right? So total these 2, 4 and 4 is duplicate in this case. Now if we'll talk about this example, example 2, in which we have 1 and 1. So these left children and this is the right children, right? Both are duplicate and values are also duplicate. Now if we'll talk about this one, example 3. So structure, this one, our subtree of this one, both are same, and that's why we can say this is duplicate because value is also same. And if we'll talk about this 3 and this 3, this is also duplicate, so we can say there is a 2 3 and another is 3. Okay, like this. Now constant we have given, right? And this question is very important, right? Because this question has been asked in Google multiple times, and Amazon is also going to ask, right? 3 to 4 times he has asked. Let's understand these questions, the implementation, how we will do the implementation, right? So the question is saying that we have the multiple approach in which if we'll talk about, there is a string representation, right? So in the string representation approach, right, what we will do, we will do in the string representation, right? So one may represent a tree with a string, and so we can say there exist different ways to do so, and one of the possible representations of a tree is like if we'll talk about like suppose representation of left sub tree, right? So how we'll do that? We'll do only root dot root dot value, right? Root dot value, right? Root dot value, and then if we'll talk about the representation of right tree, then what we will do? We'll pass the first thing, we will pass this one, and then a representation of right subtree, correct? Like this. So first we will take representation of this one, then value, and then this one, right? So like this we will use, right? So if the yeah, you can say it's a recursive representation because the parts in the bracket are representation of the smaller subtree, correct? So if we talk about we have given, right, the first we have given representation, and for this one let's suppose we have this one. Okay, let me is old, yeah. So what I'm talking about, so if we have this representation we have given, example 1 we have given, right? So if we want to represent this one, so how we will represent that? So first we have to represent what we can say the representation of left subtree. So left subtree is what? This part, right? The this is root, this is left, and this is right side. Okay, so first of all what we will do, we will do the representation of left subtree, a string representation. So first what is coming? First is coming 4, right? Then what is coming? 4 we have, and the 4 what we have? 2 we have, right? Right, right. 4 we have, then 2 we have, right? Now what we have, there is 1 we have, right? So what we will do there, we'll say we do not have anything, right? And we'll say the this part is done. Let's suppose this part is done, we are not representing this part, right? This part is done. Now what we will do, we'll say the value of this one. Now value of this one, value of one is what, we have 1, correct? Now the representation of right one, right? So how we'll do that? First what we have we can say 4 we have, right? So we'll take this one like this, and we'll say we'll take one 4 here, and we'll say 2 is there because 2 is the uh, root for 4, and we're not taking a right one, and there is 3 is also there, right? So we'll say 3 after representing this one, and then we will say 4. Okay, so what we are taking, this is a left part, this is a right part, okay, and this is our uh, root to 12. Okay, so the string representation, this is the string representation of left subtree, and this is the string representation of right subtree. What we have taken, first we have taken 4, then we have 2, and we don't have right one. Okay, similarly we'll take for the this one, so we'll take first what 4, then we will take 2, and then we have 3, and then we have 4, right? Like this we will do that. Okay, because this is also a root now. Okay, so this is the if we'll talk about this one, this will become left part, and this will become right part. Okay, like this we will do that. Now equal subtree have the equal, if we'll talk about the equal subtree have the equal string representation, right? So the different subtree, different tree have different ones, right? And to solve this problem, what we have to do, we have to represent one subtree with a string, and so we can say duplicate representation means duplicate subtree. Okay, now if you do not know the how to traverse a tree, right? So what you can do, you can do some hands-on with the binary tree, right? And then you can work on this one. Okay, or otherwise this is very easy program, right? So we will find a string representation each subtree during the post order traversal, right? So post order, you can google search out in order, post order, pre order, right? It's very easy, right? So in this case what we will do, we will find a string representation for each subtree during the post order tree traversal, right? So with the post order, at the moment we handle a node, we have already traversed its left and right subtree. So uh, so we can compose a you can say a string for the subtree of the node using the representation of its left and right subtree, right? So what we will do, we will maintain a hash map that tracks how many times each subtree, each string occurs during the traversal. If one occurs more than once, it represents duplicate subtree. Okay, so now what we will do, we will try to implement this one using the uh, algorithm, right? And the algorithm, what we will do, that first we will traverse the left subtree, we will traverse the left subtree, then we will do the node, and it will represent this one, like we will traverse node left, node, then we will have the value of this one, we will node right, we will do that, we will traverse, and then we will compose the representation of the current subtree using the left subtree representation and its right subtree representation, and this loop will continue. If the subtree occurs the second times, it means there already was the same subtree was on the current one, right? And so in this case what we will do, we will add this onto the answer, those node we will add on the answer, and we will return once the function is done, right? So what we need to do, we will call a we'll try to traverse the root node from starting, and then we'll do that. So let's go to the browser and we'll try to implement this one. Okay. First of all, we have given what? We have given a root node, right? So let me first off, let's go here. Okay. So what we have given? We have given a root node. We have given, and so that what we will do first of all, we'll take a, you can say, result of the nodes, and to do that, what we will take? One will take a result, and this result is nothing but a, you can say, we will take new and we'll say linked list, right? Linked list. Okay, sorry, linked list. Okay, and this will take what? A list of node into the result, and then we will return this one. Okay, so if we'll talk about, this is the list, right? So list will take what? Two things, this tree node, right? Tree node. Okay, now result is ready. Now we will return this result. Let's suppose if we have this one, then we will return the result, right? This is done. First we will get the result, and then we will return this one. So this structure is ready. Now what we will do, first of all, we will take one, you can say, uh, we will start traversing from what? Root node. So we can say we can say traverse will take a function, and this function will take what? You can write traverse function, right? So this traverse function will do what? Will take will start from the root node and will go to the left and right children each way, right? And in this we should pass one has map and to contain, to store the, you can say, we will store result also here. So we'll pass our result, right? So we have taken one new has map and we are passing this one, so that we will what we will do, we'll put our you can say representation over the here. Okay, so that if it's already into the, you can say, the map, means it's duplicate. Okay, so this function will create here the traverse function. So we'll say traverse function, and this traverse function will take what? Two things. Let me, it will return what? String type, right? So we'll take string as a return type, and function will take what? First it will take tree node, and it will take what? This is our node, and another it will take what? We are taking map, right? So I will pass the map, and this map will take two things, string and string as a string representation of the subtree, and then its integer, like how many times it is coming, is it duplicate or not, right? So we'll store the count here, and this is called nothing but our C, we'll say count, you can say count. And then what we will take, we'll take a list, right? So you can pass this one as this list, right? So now what we have, we can give the name exactly that we have, right? So for this we have to pass here. Got it? Now first of all, if we'll check the base case, right? If node doesn't have any value, means node is null, means root is null, then what? We don't do anything, we will return, right, blank representation of a string. We will not represent anything, we will represent null. Now we'll take a string and we'll say that a string representation will take, and this representation is what we have. First we'll start with the you can say small bracket, right? You can say this one, and then we will do the traverse, right? Okay, so to traverse, this is the function we have, right? We are doing this one. Let's call here for the subtree, left subtree and right subtree, right? So the root, first we will pass the node we have, right? So this root is nothing but our node, right? So we will pass node dot left to traverse the left subtree, and hash map we have, so this map is nothing but our counter count, and we'll pass our result, right? And once this is done, then means we are done with our you can say uh, left subtree. Now what we will do, we'll do plus, and now we have node value, root value. So here node dot val we have, right, in this case, and that we will say if we'll, if for the better readable, what you will do, you can do like this. Okay, this plus, now this is the root we have, and now we'll do enter, and we'll do for the, similarly we'll do for the left one. Okay, so I'll copy this one from here to here, and I'll put here for the right one, I'll do the semicolon, and this is nothing but our right, correct? So now what we have, first we have left subtree, now we have right subtree, and the middle one is our count, right? No, root value, right? So this part is done. Now what we will do, we will put this string representation onto the map once it is done. So I'll take we have a count, right? So I'll take the count, and on this count what we will do, just we will put what we'll call the put method, right? And we'll say, we'll pass our string representation, and the count we have, right? So count dot if we'll do the count dot get default, right? So default value, if it is not there, right, so it will take default is 0. So I'll pass the representation, and initially if there is no value, we'll take a 0. If we will have the value, then we'll do +1. Okay, now this is done, and each time is a string representation is duplicate, it will increment, counter will increment. So we'll check from the map, like if count map contains, right, if counter has been incremented, right? So for this you can say for this representation is already onto the map, so I'll do equal to 2, means it is now it is 2, means it is we found duplicate. And to do that, what we will do, we have our result, we have on the result, what we will do, we will just add this node, yeah, this node, like this. And now what we will do, we will return this representation of the string. Okay, so let me run this one. Yeah, submit this one. Yeah, great, I've completed the fabric batch. Okay, so what I have did guys here, so first of all I have taken one result, and I am returning this result, right? And now in that, what we will do, we will traverse from the root, and we'll go to its left subtree first, and then root, and the right. So if we'll talk about this one, this is nothing but our left, right, and root. Okay, so if we will have this representation getting, if this representation is initially coming, so we'll put as a 0 as a counter. If next time it is coming, we will increment the counter, and we'll check from the map. If it is already there, it means we have to add on to the duplicate result, and we'll return this representation finally. Okay, so thank you so much guys. If you like this video, please hit subscribe to this channel. And if we'll talk about the, you can say complexity, right? So complexity is see, we are going with all we are doing the string representation, right, for each subtree. Here, like we are doing for left, then we are doing for right, for each node, right? And so that what we will do, here it is coming O of n times, here is also coming O n times. So while creating this representation, therefore cost is O of n, right? And we find the string representation for all n, right? For all n, you can, for all nodes, you can say, right? We are passing nodes, and we are going for this one and this one 2 times. So that's why we can say if we'll talk about complexity, right, so it will become what, O of n. Okay, O of n square, you can see, sorry, where is that? Yeah, O n square. Okay, like this. And similarly space is also like this also. Okay, and space complexity also same. So thank you so much guys. If you like this video, please hit subscribe to this channel, so that and why space is a of n square, because we are storing into the you can say uh, map, right, onto the map, as well as we are storing onto the you can say list, right. Thank you so much guys, thank you so much.